Well, let's find the derivative of this. Okay, let's do it the hard way, but not on the board. Let's do it the hard way in our head, and then we'll be like, oh, wait, that's too much. Okay, quotient rule. We agree with the quotient rule. It's sine divided by cosine. And so we do the quotient rule. In the process of doing the quotient rule, you'd have to do the chain rule here and the chain rule here. But if you're really looking at this with a really keen trigonometric eye, you've noticed that you have sine of something over a cosine of that same thing. Sine over cosine is tangent. So what we really have is tangent of 2x. Now, if this was a 2 and that was a 3x, it'd be different. Couldn't do it. But for now, we can. So I'm just going to take the derivative of tangent of 2x, which is chain. And so the biggest thing happening in our chain rule, and it's just a chain. It's not chain with anything else. We just eliminated the need for the quotient rule by saying sine over cosine is tangent. So the biggest thing happening is that somebody got tan. And the derivative of tan is something that a lot of people forget, but it is not negative. The co's are negative. The derivative of a co is negative, but the derivative of tangent is positive, secant squared u. Okay? G is 2x. G prime is 2. Okay. Chain rule says we're going to take this, plug it in there. So we're going to have secant squared of 2x. And then multiply by 2. The 2 would go at the end if we wanted to leave it in the sloppiest format ever. Let's not do that. Don't multiply this 2 with that 2. Let's just put the 2 in the front. There we go. That's that one. Let's do this last one on the front. And it says x times the square root of x squared plus 1. Let me write that down. X times the square root of x squared plus 1. Okay, in the process of saying that out loud, you said x times, sounds like product to me, right? X times the square root of x squared plus 1. So we're going to do product rule first. So the biggest thing happening is product. And the first thing we multiply by is f. The derivative of the derivative of x is 1. And then this one is the square root of x squared plus 1. And just for the sake of a rewrite, let's really call it what it is. This is x squared plus 1 to the 1/2. And I need to take the derivative of that. And that is, well, I'm taking the square root of something that is a function itself. It's a little more complicated than just x, right? So we need to use the chain rule on this one. So chain, let's switch colors just so it doesn't all run together. What color should I use? Not the pink one, it's running out. Green one doesn't show up. Red shows up pretty well, surprisingly well. The biggest thing happening over here is that somebody got square rooted, so we're going to call that u to the 1/2. The derivative of u to the 1/2 is, okay, well, 1/2 u to the negative 1/2. So 1/2, that's great, but that negative 1/2 sends the u to the denominator, then we take a square root, so we're going to have 1/2 square root of u. There we go. The derivative of square root of something is that. It's just a good thing to know off the top of your head. And you click twice when you know it, apparently. G is the inner function, x squared plus 1. The derivative of g is 2x. And we are going to use the quotient. No, we're not. Quotient. Where'd that come from? We're going to use the chain rule for this. Take this, plug it in right there. 1 over 2 square root of x squared plus 1. And then we will multiply by 2x. So we're going to multiply this thing by 2x. Let's put it in the numerator. So 1 times 2x is 2x. And so at this point we'd say, oh, I see those 2's. They cancel. So x over square root of x squared plus 1. Okay, now we're ready to get back to the product rule, which is f prime g plus f g prime. So let's do it. Back to the product. Final answer, like h prime is equal to f prime g. I'm going to use the square root on this one. Plus f g prime. Okay, thinking ahead here. X times x over that. Well, x times x is x squared. There we go. Okay, correct. Totally correct. Leave it like this. I'm happy with this, but if this was multiple choice, this may not be an answer. And so what I'm going to do is take it a little bit further. I'm going to actually go backwards with it because I'm running out of room. So Sorry, not the best mathematical thing to do, but we'll do it. You can go down on yours if you want to. But I'm going to multiply both fractions. Let me rephrase that. I need a least common denominator, and my least common denominator is that. It is that square rooted denominator. So I'm going to keep that second fraction the way it is, and I'm going to get that denominator in the first fraction. And if I'm going to multiply by that in the denominator, I need to multiply by that same thing in the numerator. So basically, multiplying by the square root of x squared plus 1 in the numerator and denominator puts it in the denominator and then cancels the square root out of the numerator. So I'd have square root of x squared plus 1 times square root of x squared plus 1. That's just x squared plus 1. Add these fractions. So my final answer, we'll bring it down here. It's going to be a big sloppy mess. X squared plus 1. Square rooted is my denominator. My numerator is x squared plus 1 plus x squared. That would be 2x squared plus 1. And that would be a really good multiple choice question where that is not the answer and you'd have to go a little bit further with it.